Most videos and blogs I've seen comparing AI, machine learning, deep learning, and generative AI are either too basic or way too technical and unclear. So I have two goals for this video. For our viewers with no technical background, I'll explain these terms very plainly just so you could truly understand them and be able to use them more confidently. And for our technical viewers, I will go a step further and touch on the technical details, just so you could also walk away feeling like you've learned something new. Okay, so AI, machine learning, deep learning, and generative AI are very closely related terminologies, so they're not like very divergent ideas. And here is a simple analogy to show you how they fit together. Imagine you wake up in the morning and you're deciding on how to get to work. And let's say you decide you want to get to work faster. At that point, it's just a goal, an ambition that you have. You don't yet know how you will achieve it. In the same way, artificial intelligence began as the idea of building machines that could think and act intelligently. Early on, researchers didn't know exactly how that intelligence could be implemented in machines. Moving on, let's say to reach your goal of getting to work faster, you choose to drive instead of walking. Now you have a practical method for getting to work faster. In the same way, machine learning is one practical way of achieving intelligence in machines. You're not longer just imagining intelligence. Next, let's say you upgrade to a modern high-performance car. The idea hasn't changed, it is still to drive to work, but you're now using a faster, more capable vehicle. In the same way, deep learning is still machine learning, but a more advanced and powerful version of it. Generative AI is what becomes possible with that powerful vehicle. The car can now drive itself, plan routes, and even suggest new ones. It's not just getting you to work, it's creating new ways to get there. Now, like with most analogies, ours isn't perfect, but hopefully it helps you see the big picture that you can think of these terms as a set of nested ideas where artificial intelligence is the big umbrella. The idea of building machines that can learn, reason, adapt, and make decisions in ways that resemble human intelligence. Machine learning is a subfield of AI. It is essentially a practical way to achieve AI in machines. Now, with machine learning, instead of hard coding rules, we show systems a bunch of examples and let them learn the rules on their own. Deep learning is a subset of machine learning. It is a more advanced form of machine learning, basically. It uses neural networks inspired by the human brain to learn complex patterns automatically. Generative AI refers to systems that create new content such as text, images, music, or code by learning patterns from existing data. Although generative AI is not a strict subfield of deep learning, most modern generative AI systems rely heavily on it. So you're currently seeing 4 statements on your screen. 2 of these statements are false. Your task here is to pick the ones I think are wrong and let us know why in the comments. You can actually just pause the video here and think a bit. So earlier we mentioned that machine learning is about showing an algorithm a bunch of examples and having it learn the rule on its own. But what does that actually mean? To truly understand that, let's start with the simplest case we could think of. Imagine we have a small table of numbers. You give the system a value x and it gives you a value y. Now, even as humans, after seeing a few examples, we start to notice a pattern. The output is just the square of the inputs. So for example, 1 times itself is 1. 2 times 2 is 4. 3 times itself is 9, and so on. We can describe that pattern with a simple rule: f of x equals x squared, or y equals x squared. And once we know that rule, we can predict new values. So for example, if x is 5, we already know that y will be 25. This is the core idea behind the machine learning. Instead of hard coding the rule, we show the algorithm many examples and let it learn the rule for itself. In other words, it learns the mathematical relationship that best maps inputs to outputs. Now, this example is ridiculously but deliberately kept simple, because in real life, the patterns are rarely this obvious. Take something like predicting house prices. Each house might have many inputs like size, number of bedrooms, location, age, and more. The relationship between these inputs and the final price is not a clean formula you can easily write down. Machine learning shines here. By studying thousands of real house sales, the model learns how these factors interact. It learns which features matter more, which ones matter less, and how they combine to influence the final price. Even when the pattern is too complex for humans to articulate, the model can still learn it from the data. But this approach has a limit. Traditional machine learning relies heavily on a list of attributes like the number of bedrooms, the location, etc. These attributes influence a house's price, and this is why we choose them rather than the house color, for example. We call these attributes features. They are the inputs humans define in advance. As long as the problem fits neatly into rows and columns, traditional machine learning would always work well. But once the data becomes messy or unstructured, think images, audio, text, deciding what features matter becomes extremely difficult. Humans struggle to describe those features explicitly. This limitation is what leads us to the next step in the story: deep learning. Now, let's talk about deep learning. And earlier we've said that deep learning is still machine learning, but it is just a more modern and more powerful version of it. And that's because deep learning is built on something called a neural network. But what is a neural net really? Quick disclaimer, I'm going to make a few generalizations here just to keep things simple. So I apologize in advance to the experts in the field watching this video. But let's move on. At a high level, a neural network is just a system made up of many tiny units called neurons connected together in layers. Each neuron looks at every input, does a simple calculation, and passes the result forward. On its own, a neuron is not impressive, but when you stack thousands or millions of them together, something powerful happens. And here's the key idea. The early layers learn very simple patterns. Later layers take those simple patterns and combine them into more meaningful ones. Unlike earlier machine learning models, neural networks do two things at once. They don't just learn how to make a final prediction, they also learn which features matter in the first place. Let me make this concrete with an everyday example: face unlock on your phone. With traditional machine learning, a human has to decide what features the model should use. Things like the distance between your eyes, the shape of your nose, and the width of your mouth. The model then learns how those hand-picked features map to your identity. But the problem is that the real world is messy. Change the lighting, put on glasses, or grow a beard. Suddenly, those features stop working so well and the system struggles. Deep learning takes a completely different approach. Instead of telling the system what to look for, we just show it many pairs of photos and teach the network to recognize whether they're the same. This is how it will later recognize whether your face matches the one in the database. No handcrafted features, just learning directly from raw pixels. Instead of relying on human intuition to define the right input, neural networks discover them themselves. That shift, learning the features and the patterns together, that's the heart of deep learning. Lastly, let's talk about generative AI, the kind of AI behind tools like ChatGPT. Most modern generative AI systems are built using deep learning. Even though we call them generative, they are still doing something very familiar under the hood. They are predicting. Essentially, they are still predictive models, but let's clarify that in the context of large language models, LLMs. Note that there is more to generative AI beyond LLMs, but for simplicity's sake, we will limit our conversations here to just that. And let's cycle back to the points we were trying to make. How are LLMs just predicting under the hood? Okay. During training, an LLM is shown a huge amount of real text, books, articles, emails, and more. Its job is not to write anything new yet. At this point, it just learns patterns by doing one simple task again and again. Given some text, predict what comes next. For example, if the training text is "the cat sat on the mat," the model might see the cat and try to predict the next word, sat. How this prediction happens is it guesses, check how wrong it was, and adjusts itself slightly. Then it repeats this across millions of examples until it becomes very good at predicting what humans typically write next. Over time, it learns things like grammar, tone, and common phrasing, not by memorizing rules, but by absorbing patterns from real examples. Once training is complete, we stop updating the model and deploy it for use in the real world. Now, here's a typical flow of what happens under the hood when you use an LLM. We're simplifying lots of things here, of course. You give the model a prompt, it predicts the next word, that word gets added to the original prompt, then it predicts the next word and repeats the cycle again and again until it predicts a special word that signifies the end of an answer. So the model is not really thinking up an answer in one go, it is building it one step at a time through repeated prediction. But here is why it still feels creative. At each step, the model usually has a few good options. For example, after the cat, it could reasonably choose sat, ran, or jumped. A small amount of randomness helps you pick among these sensible options instead of always picking the same one. That is why the output feels fresh and human. It is not copying a past example, it is creating a new one by following patterns it learned from many real examples. To wrap things up, artificial intelligence is the big idea of building machines with human intelligence, or at least the semblance of it. Machine learning is how we achieve AI. Basically, it is a subset of artificial intelligence. Now, deep learning is just a more powerful, more modern, and smarter version of machine learning. Generative AI, on the other hand, is what becomes possible when deep learning models start creating new content. Okay, if this video has helped simplify these terms for you, please like the video. It helps the channel reach more people interested in learning AI. And if you want more simple explanations like this, subscribe to the channel as well. It would mean a lot to me. Lastly, we've written a more comprehensive blog post on this subject matter. I will leave a link to it in the description. Thank you for watching, and I'll see you in the next one.